Hello GMS students, this is Mr. Friedman, and today we are going to be looking again at solving systems of equations using the elimination method. Now before you begin watching this video, please download the guided notes which are on Google Classroom. If you have a printer, you may print them out. If you do not have a printer, please copy down the example that's in the guided notes before starting the video so that you can follow along. Now, in yesterday's lesson, we looked at an example where we had to multiply one of our two equations by a number in order to get one of our variables to eliminate. In today's lesson, we are going to be looking at the case where we have to multiply both equations. So let's look at this system of equations. So if I want to eliminate either x or y, I can't do that by just multiplying one of my two equations, right? I can't multiply 3x by any number in order to get it to equal negative 5x. Okay, and I can't do that with 2y. I can't get that to be 5y by multiplying by a number, by multiplying by a whole number. So what we're actually going to do is multiply both of our two equations in order to get a variable to eliminate. Now I could eliminate either x or y. Either is going to be relatively easy. Let's think about how I could eliminate y. Now I need my coefficient to be the same. So let's think about what is my least common multiple of the coefficients 2 and 5. Well, my least common multiple of 2 and 5 is 10. So that's what I'm going to want to make the coefficient on y. So to get the coefficient of my first equation to be equal to 10, I'm going to have to multiply this equation by 5. My second equation, if I want this coefficient to equal 10, I'm going to have to multiply this equation by 2. Now notice here I didn't multiply either of these by a negative number. That's because I already had opposite coefficients on my y. Remember, when I do the elimination, I want one positive and one negative so that the variable will eliminate. I already had a negative and a positive, so I don't need to change the sign, so I multiply both by a positive number. So now let's do the multiplication and find our resulting equations. My first equation becomes 15x times 2 minus 10y equals 10. That's what we get when we multiply our first equation by 5. Let's look at our second equation. Negative 10x plus 10y equals negative 20. Now we see that we have a zero pair in y. So y is going to eliminate when I add the two equations together. When I add my equations together, I get 5x, y eliminates, equals negative 10. Now we can solve for x. Divide both sides by 5, and I get x is equal to negative 2. Now to solve for y, I can plug in my value of x into either of my two equations. I'm going to use the first equation, 3x minus 2y equals 2. Remember, I copied this equation, but I left a blank for x because I now know that my value of x is negative 2. So now let's go ahead and solve this equation. 3 times negative 2 gives me negative 6 minus 2y equals 2. Solve this equation. I add 6 to both sides. Negative 2y equals 8. Divide both sides by negative 2. And we get y is equal to negative 4. So my solution to this system, I write as a coordinate pair, negative 2, negative 4. Our final step is we are going to check the solution in both of the two equations. So start with the first equation, 3x minus 2y equals 2. Okay, so I left blanks for both of my variables because I now know what they are. So let's substitute that in. Negative 2, negative 4. 3 times negative 2 gives me negative 6. Negative 2 times negative 4 gives me positive 8. And we get, I get negative 6 plus 8 gives me 2. It's equal to 2. Sorry about the little mistake there, but this equation does check. I get 2 equals 2. Now let's take our other equation. Negative 5x plus 5y equals negative 10. Again, we're going to plug in the solution that we found here, negative 2 for x and negative 4 for y. So negative 5 times negative 2 gives me positive 10, plus 5 times negative 4 is negative 20, equal to negative 10. 10 plus negative 20 is negative 10, equals negative 10. So that equation also checks. So this is our final method of elimination that we will use when we have to multiply both equations by a number in order to get a variable to eliminate. And now you should be ready to begin today's assignment.